test tube reactions can be used to identify the functional groups in organic molecules. You're provided with samples of each of the 4 compounds shown. Describe how you could distinguish between all 4 using the minimum number of tests on each compound. Describe what would be observed in each test. This is worth 6 marks. This looks like it's the level of response question for the paper, given the sort of spread out of the page. Also, this is a question that is asking us about required practical 6, so it's covering like practical aspects of the course as well as the topic organic analysis from the first year. So there's going to be more than one right answer. The way that I work through this may be different to yours, but we do need to have it in the minimum number of tests. Because it's a level of response, then they will be looking for logical conclusions and a logical flow to your answer. It's covered all the different areas, and so really what they'll be looking for is that you could do this in 3 tests. So did you do it in 3 tests? Did you logically eliminate things and not reuse them? So did you follow the instructions? First thing I'm going to do is identify functional groups. I've got an alcohol here. That alcohol, important to classify alcohols. So that is the carbon attached to it is 2. Secondary alcohol. I've also got this is a carboxylic acid. I'm just going to write Ca there for myself. Here I've got a primary alcohol. Primary and secondary react similarly in these functional group tests. I've got a halogenoalkane, bromoalkane. The next molecule, I've got a carboxylic acid only and nothing else. And in my last molecule, I have got a CHO, an aldehyde. And I've also got another halogenoalkane, the same one. So I'm not going to be able to tell them apart by different colour precipitates. So this is bromo again, a halogenoalkane. Now, if I look, the halogenoalkane appears twice. The alcohol appears twice, carboxylic acid appears twice, but aldehyde only appears once. So the thing I think I'd probably do to start off with is remove N from my samples by doing a test for an aldehyde. I'm going to warm with Tollens reagent to create a silver mirror on the aldehyde one. You could pick Fehling solution here as well, but either will work. So the number 1 test I'm going to do, react all 4 samples with Tollens reagent. And with Tollens and Fehlings, you do need to warming in a water bath. You do need to warm them. In a water bath. N only will produce a silver mirror. So Tollens and Fehlings are a very specific aldehyde only test. They don't give the same observations with anything else. So I would get those out of the way first. Okay, so by doing that, I have now decided which one is N. I no longer need to test N. And by crossing that out, I now only actually have one thing that is a halogenoalkane. So I'm going to try and find that by doing test 2. And my test 2 is going to be to add silver nitrate solution to the samples and warm. You may need a bit of ethanol as a mutual solvent here if you were doing this in the lab. And then a cream precipitate. Actually, we should write the full word. This is level of response. So this is just to the 3 remaining. So we'll get rid of L. So now we've got rid of L. We've got 2 carboxylic acids, but one of them's also an alcohol. So I could do test 3, find the one with the alcohol. We're going to warm with acidified potassium dichromate, and then only the very first one, K, will turn from orange to green. So this is one set of tests. It's the minimum number of tests. 3 is the minimum you can get away with here that will identify them all. Let me go through a different collection of tests we could have done. So we could have started with something that didn't just find the one that we could find. So we could have split it into 2 groups. So for example, we could have added sodium carbonate, and then K and M would have fizzed and L and N wouldn't have. And then, in order to distinguish K from M, we could have done the heating with acidified potassium dichromate. Then we'd have known which one were K and which was M, and then we could have done the Tollens, and that would have given us the aldehyde as well. So there's different ways that you could approach this, but it did need to be 3 tests, not 4, because 3 tests will allow you to identify them all.